Okay. Hello. Welcome to the International Free Webinar. Thank you for joining us for this wonderful evening. I am your host for tonight. My name is Rohamina P. Gapor, currently living in Thailand. It is my pleasure to be part of the Institute of Global Professionals. To all the new participants, welcome. And let me give you a little bit background about IGP. Institute of Global Professionals is an educational institution that provides social work with globally recognized. IGP is a leading online skills development institute with thousands of learners worldwide. We have organized this webinar, training, offline, and online courses from best and trained speakers, trainers from all over the world to create a best learning platform for all of you. We believe that it's not effective to increase one's skills just by acquiring formal education. So we provide essential training, consultation to generate proficient generation all over the world. Our mission is to empower people and improve their skills. As IGP's mantra, feed your skills. And we have completed 133 webinars, and tonight we are happy to bring you 134 webinar on the topic Magic of Logic with two brilliant speakers, Dr. Cesar R. Cairo and Sir Paul Gary P. Abelio, all the way from the Philippines. So please, our lovely audience, don't forget to share this webinar in your community, tag or mention your friends in the comment box or comment section down below. And we expect that tonight's webinar will help you to improve your personal and professional life. Okay? So now, without further ado, I would like to welcome the first speaker. Our first speaker is Teacher Tree from Muntinlupa Science High School. He is a mathematician and public speaker. Okay, so please help me welcome our first speaker, none other than Sir or Dr. Cesar R. Cairo from the Philippines. Sir, good evening.
Good day, everyone. I'm Cesar Ramos Cairo, and I'm a math teacher from the Philippines. I earned a Bachelor of Secondary Education major in Mathematics in 2004, followed by a Master's degree in 2013, and a doctorate in 2017. I've been teaching for about 17 years, and I'm presently in charge of the Senior High School Department at Muntinlupa Science High School, where I teach general mathematics, statistics, and probability. Throughout my teaching career, I coached our mathematics team and was elected as our school's faculty president. I am grateful for the opportunity, and I'm excited about sharing what I know with everyone who will be attending this webinar. Thank you and God bless.
Please let us give a warm welcome to our first speaker, Dr. Cesar R. Cairo. Sir, thank you so much for your time and to attend this wonderful webinar tonight.
Hello.
Yes, sir. Good evening, sir.
May I start now, ma'am?
Yes.
May I share my PowerPoint presentation?
Sure,
Okay.
sir.
Okay, this is my ma'am.
Yes, sir. Very clear, sir.
Okay, how about my PowerPoint presentation, ma'am? Do you see that, ma'am?
Yes, sir. Yes, sir. Yes, sir.
Okay, may I start now, ma'am?
Sure, sir. Good luck, sir.
Okay, once again, good evening, everyone. Okay, thank you. Once again, good evening, everyone. And I pray that all of you who are participating in our webinar today are doing well and that you are all safe. But before we get started, I'd like to express my gratitude to everyone who helped put this webinar together. I am extremely proud and pleased to have been chosen as one of the presenters for today's session and to be able to share what I know with everyone. First and foremost, we give thanks to our Almighty God for His kindness and goodness, to the Institute of Global Professionals for providing a venue for continuing information sharing even in the face of pandemic. Of course, to our Muntinlupa Schools Division Superintendent, Dr. Domenico C. Idanan, for his, of course, unwavering support to our APS Mathematics, Dr. Emilita Bautista, for always believing in us. To our Chief of Curriculum Implementation Division and the same time our OIC Principal of Muntinlupa Science High School, Ma'am Madeline Ann L. Diaz, for encouraging and instilling confidence in us. To our Munsay family, particularly the mathematics and senior high school departments, for your inspiration and motivation. And finally, I'd like to express my gratitude to my loving and supportive family. So once again, I am Cesar Arcairo and I work for the Department of Education in the Philippines as a senior high school mathematics teacher. So I've been given the task of presenting the topic about the logic in today's webinar. So let's start. Okay, so um, this is all about the propositional logic. No? As we know that the logic is the basis of all mathematical reasoning and all of automated reasoning. So the rules of logic specify the meaning of mathematical statements and proposition is the basic building block of logic. And the propositional logic is a mathematical system for reasoning about propositions and how they relate to one another. And the propositional logic enable us to formally encode how the truth of various propositions influences the truth of other propositions, determine if a certain combination of propositions are always, sometimes, or never true. And lastly, determine whether certain combinations of propositions logically entail other combinations. So, but before that, let's give the definition of the propositions. It is a declarative sentence that is either true or false, but not both. And what is the declarative sentence? A declarative sentence does not ask a question, give an order, or express strong emotion. It is simply make a statement. They pass on information. A declarative sentence always ends with a period, full stop. Okay, full stop. Now, look at these some examples. We have 5 million people are at risk. Manila is the capital of the Philippines. She asked whether I like her dress. As you can see in example letter C, she asked whether I like her dress. Even though this is an indirect question, it is still a declarative sentence because it is a statement. No? Notice that none of these sentences ask a questions or give an order or shows tremendous emotions. So take a look at the example. Once again, it does not provoke a reaction. No, it makes a statement. Another one, 5 plus 6 equals 11. Obviously, 5 plus 6 equals 11 is a true mathematical sentence, but is it a declarative sentence? Yes, that's a declarative sentence. To see this, notes that you may read it as 5 or the sum of 5 and 6 is 11, which is clearly a declarative sentence. Therefore, it is a true proposition. How about this? F of x is equal to square root of x over x plus 1 is a rational function. This is a declarative sentence. Since the numerator of the function is not a polynomial, the function f is not rational, and so the statement is false. Therefore, this is a false proposition. You can remark that false mathematical sentences are still propositions. So there are the following not a proposition. No? Where is the brown building? Who are you? So that is interrogative sentences as a direct question and are therefore punctuated by a question mark at the end of the sentence. Another one, wait for the light to turn green. Get out of my face. This is imperative sentences are used to give a command, request, or instruction period. However, an exclamation mark is occasionally used. Another example, what an amazing sunset. That is exclamatory sentence. So exclamatory sentences are statements that shows a strong emotion or feeling. Exclamatory sentences are generally distinguished by their punctuation mark. All exclamatory sentences end with a full stop. Okay, those are the example of not a proposition because this is not a declarative sentence. Okay, let's continue. So a proposition has exactly one truth value, true, which we denote by capital letter T, or false, denote by capital letter F. So these are the following angles. So that is a true proposition. 3 plus 4 equals 9, and that is false proposition. If today is Monday, then tomorrow is Tuesday. So that is true proposition. And the propositional variables are variables that represent propositions, just as letters as you are used to denote numerical variables. The conventional letters used for propositional variables are P, Q, R, S, and so on. Again, if a sequence of proposition is considered, we denote the propositions by n sub 1, n sub 2, or even p sub 1, p sub 2, and so on. Now, what are the types of propositions? So we have here simple propositions. That is a proposition that expresses a single thought. It is not composed of any other propositions. Like a simple sentence, it only has one subject and one predicate. Example, the sky is blue. The measure of a right angle is 90 degrees. So that is for simple propositions. While the compound proposition contains two or more simple propositions that are put together using logical connective words such as and, or, if and then, and if and only if. Example, the angle measures 90 degrees if and only if it is a right angle. Another one, If today is Monday, then tomorrow is Tuesday. Okay, let's try this. So if you know the answer, just type your answer to the comment section. Determine if the following sentences are propositions. If so, determine if it is simple or compound. Let's start. Elephants can fly. Is that a proposition or not? And what type of proposition? Okay, very good. That's a simple proposition. It is a proposition because it is a declarative sentence, not a question, exclamatory, or imperative statement. It is a simple proposition because it only has a single thought. Very good. How about this one? Are you and mom coming to the game tonight? What do you think the answer? Correct. That is not a proposition. It is a question, not a statement. That's correct. How about this? If x equals 5, then 4 is less than x. Okay, that's a proposition. But this is a compound proposition because it composed of two simple propositions. How about this? Her dress is pink and her blouse is yellow. What is the answer? Proposition. And what type of proposition? Compound. It is a compound proposition because it is formed by combining two propositions with the word and. Okay? How about the last one? The number 6, 8, and 10,000 are even numbers. Okay, that's correct. The answer is proposition, and that is simple proposition. Even though the sentence construction composes of three subjects, 6, 8, and 10,000 are even numbers. It only expresses a single thought. Now, let's proceed now to the logical connectives. The connectives are the operators that are used to combine one or more propositions. And in propositional logic, there are 5 basic connectives. What are those? Okay, the first one is the negation. Second is conjunction. The third one is disjunction. Next, we have conditional, and the last one is the biconditional. Again, these are the following, the 5 basic connectives or the logical connectives. So let us, I'm going to show you the name of connective, the connective word, and the symbol. So that is negation. The symbol resembles a dash with a tail. Okay, the arithmetic subtraction symbol or tilde, or in geometry, that is a similar symbol, are also used to indicate logical negation. Then we have here conjunction. Okay, it is the small wedge, denotes end. And for the disjunction, the upside down wedge denotes or. Then the fourth one is conditional, implies or if then. In geometry, that is a raised symbol. And the last one is biconditional. The word is if and only if. It denotes that if and only if. In geometry, that is a line symbol. Okay, so those are the name of connective word, and symbols. Okay. Now, what is the truth table? The truth table represents the relationship between the truth values of propositions and compound propositions formed from those propositions. The important tool in logic is the truth table. Okay, we may use the truth table to illustrate all the possible truth value combinations of two or more propositions. So let's suppose that P and Q are propositions. We can make a truth table that shows the relationship between the proposition truth values of P and Q, the value of P and the truth value of Q. So the rows of the table will correspond to each of the possible P and Q truth value combinations for a total of 2 squared equals 4 rows. So as a result, we obtain this table for the propositions Q or P and Q. Okay? Now, assume that P, Q, and R are propositions. Then, there are 2 cubed equals 8 rows in the truth table involving the given propositions. So, in general, a truth table involving n propositions has 2 raised to n rows. Okay, let us discuss now the first logical connectors. We have negation. It is a simple proposition that denies the truth of the given proposition. That is, the negation statement is false whenever the given statement is true, and true whenever the given statement is false. In logic, guys, negation also called the logical complements. So the negation can be obtained by inserting the word not in the given statement or by prefixing it with phrases such as it is not the case that. Example, we have your proposition is the sky is blue. Therefore, the negation is the sky is not blue. Another one, the proposition is square root of 2 is a rational number. The negation, it is not the case that the square root of 2 is a rational number. Okay? So, uh, it's sometimes important in mathematics to figure out what the opposite of a given mathematical statement is. This is commonly known again as negating a statement. It is important to remember that if a statement is true, its negation is false. And if a statement is false, then its negation is true. Okay? Look at this. The negation of statement P is not P. The negation of P is symbolized by negation of P. That is still there P. Okay, not P. The truth value of negation of P is the opposite of the truth value of P. Okay, let's look at some more examples of negation. We have the proposition the number 9 is odd. Therefore, the negation of P, the number 9 is not odd. Okay, another one, proposition Q, the product of two negative numbers is a positive number. So the negation Q, the product of two negative numbers is not a positive number. Okay, now, it is a common mistake to assume that the proposition not P is automatically false just because it involves a negation. However, negation of P can be true, no? Negation of P can be true. This happens when P is false. For example, 7 is less than 5. So your proposition is false. Therefore, the negation of R, 7 is greater than or equal to 5. Okay? Now,
Okay, we have some technical problem. Okay, so I think it's on the system. Okay. Yes, mom. There is a problem on the system, so we hope that everything will be okay. Just wait. So before we proceed, so or while waiting for our speaker, because I think there is a some technical problems. So when you heard the word magic or magic in logic, magic in logic, what comes first in your mind? I have read some comments here. She defined what is a logic and what is magic. Okay. Sir Gary, we have some technical problem, so we're trying to fix it. Please wait. Okay, so our lovely audience, in your own opinion, or when you heard the topic magic in logic, what comes in your mind? Okay, according to Sir Jerry, there is a spectacular things in logic. Okay, yes, very good. And according to Mom Janine, she says that logic is what you think and magic is what you do. Wow, I like it. Yes, yes, Mom Marisa. So there is a unstable net connection. Okay. Okay, so Mom Marisa, yes, logic from mind. Yes, magic or logic. It sounds interesting. Yes, Sir Joshua. Actually, I asked myself, what is the logic or behind magic? Right? It's interesting. It's quite interesting. Yes. Magic is an application of logic. Mm-hmm. Yes, Sir Jerry. The secret to understand logic easily and wisely. Why did you say that, Mom Erina?
Sorry
Yes,
for
Mom Ruth, we have some
the
technical problems in our system, so please wait. Oh, okay, sir.
error. Sorry, that's a technical error.
Yeah, that's okay, sir. So
Sorry,
please continue,
participants.
sir, while I'm reading the comments from our lovely audience, so you can present again your presentation.
Okay, again, once
Shall we
again, sorry,
go?
participants. So let's continue. Sorry again, sorry. So I can share my PPT.
Okay. So while waiting for sir, mom, mom Nell or sir. Okay. I think the magic is a logic is amazing because it provides you detailed explanation to a given situation. Wow. Yes. Yes, sir, Esterlita, please wait. Because now we have some technical problems, so I hope everything will be okay. Sir, you can present again your
Okay,
presentation.
okay, let's continue. Once again, participants.
Logic involves critical thinking. Okay, sir, no problem. I
Sorry.
cannot afford that kind of problems. Okay. So,
Okay,
sir, good luck.
loud and clear, loud and clear.
Yes, sir, loud and clear.
Okay. Okay, thank you once again. Let's continue. I think we will proceed to answer the following exercises here. Okay, again, determine the negation of the following statements or expressions. We have, I love traveling. Again, I do not love traveling. Simply insert the word not. And then the proposition A equals 5. We may also say, it is not the case that A equals 5. Okay? Then the third one, you are not a musician. So to negate statements with not, simply omit the said word. Not. Okay? Then the shoes are brown. So for negation, simply insert the word not in the statement to contradict it. So the shoes are not brown. And lastly, 64 is not equal to 9 squared. We may also say it is not the case that 64 is not equal to 9 squared. So to negate the not equal sign, just replace it with the equal sign. Okay. So let's proceed to the second logical connectors. We have conjunction. It is proposition formed by combining two propositions called conjuncts with the word ends. By the way, the conjunction do not always use the word ends. Words like but, even though, yet, and while are also used to plug conjunctions. Example, Edward is competitive and hardworking. Edward is competitive but hardworking. Edward is competitive yet hardworking. Although Edward is competitive, he is hardworking. While Edward is competitive, he is hardworking. This sentence or these sentences differ somehow from the standard language. However, in logic, we are only interested in whether the statements or the propositions is true or not, as well as how the truth value of the compound propositions is affected by the truth value of its simple components. As a result, all of these propositions may be expressed in logic by the conjunction P and Q, where P is what? Edward is competitive and Q is Edward is hardworking. Okay? So the connective and implies the idea of both. For the conjunction P and Q to be true, both P and Q must be true. So this is the truth table for P conjuncts Q. Observe that the first two columns contain all the possible combinations of truth values of P and Q. We started with having both true as their individual truth values and ended with having both false. So the third column reflects that P conjuncts Q is only true when both P and Q are true. Very clear. If P and Q are true, therefore P conjuncts Q is also true. Okay. So exercise number 1. Let P represents 3 less than 5 and Q represents 3 is greater than 5. Find the truth value of P conjuncts Q. Okay. The statement 3 is less than 5 is true. Right? Hence P is true. The statement 3 is greater than 5 is false. Hence Q is false. Since one of the two statements is false, therefore P and Q is false. Okay? So the answer is false. Exercise number 2. Construct the truth table for the compound proposition P conjuncts negation Q. So first, write all the possible combinations of truth values of P and Q. Then get the negation of Q. As you can see in the third column, that is the negation of the second column. And then the question, what is the value for P or the truth values for P conjuncts negation Q? As I recall, there are only one true conjuncts if two propositions are true. So therefore, the second rows, that is only true. Okay? Next, consider the propositions P and Q below. What values of X will make P conjuncts Q true? So the proposition X plus 2 equals 3 and the second proposition X raised to 0 equals 1. So proposition P will be true when? If X plus 2 equals 3. Simplify the equation, proposition P is, or simplifying the equation, proposition P is only valid when X equals 1. So that is true if X equals 1. Okay? While the proposition Q will be true if X is raised to the power of 0 equals 1. Since all numbers when raised to 0 is equal to 1, X can be any number. Since X is the same variable used for both P and Q, this must have the same value. Take note also that there is no other value of X except 1 for proposition P. Therefore, P conjuncts Q will only be true when X equals 1. How about this? Consider the following situation. In a college, students are randomly selected. A certain number like soft drink, a certain number like milk tea, and a certain number like both soft drink and milk tea. So let S be the students who like soft drink. Let M be the students who like milk tea. Then show in a Venn diagram where is S conjuncts M, negation S conjuncts M, S conjuncts negation M, and negation S conjuncts negation M. Okay, so the shaded parts, no? The shaded parts of the shaded parts represents the students who like both soft drinks and milk tea. So that is S conjuncts M. The second Venn diagram, the shaded parts represents the students who do not like soft drink but like milk tea. So that is negation S conjuncts M. Third Venn diagram, the shaded parts represents the students who like soft drinks but not like milk tea. So that is S conjuncts negation M. And lastly, the shaded part represents the students who do not like both, who do not like soft drink and do not like milk tea as well. So that's negation S conjuncts negation M. Okay, so let's try this. Consider the following propositions. X plus 1, or the first proposition, X plus 1 is less than 5. Proposition Q, the absolute value of X plus 7 is equal to 9. And proposition R, X squared plus X minus 6 equals 0. Okay? Write all. Okay, I have here the question. What is the greatest possible positive value of X so that P conjuncts the quantity Q conjuncts R is true? So first, write all the possible combinations of truth values of P conjuncts Q conjuncts R. Now, based on the table, P conjuncts Q, conjuncts R is true only if Q and R are all true. Okay? So as you can see in our first row, okay, all values are true. That's why the P conjuncts quantity Q conjuncts R is also true. Okay? Now, okay, let's try to answer the question, what is the greatest possible um, positive value of X so that P conjuncts quantity Q conjuncts R is true? Okay, so for the proposition P, let's solve each mathematical sentence to find the values of X that make the proposition true. So proposition P, we have X plus 1 is less than 5. So therefore, X is less than 4. That is for the proposition P. And for the proposition Q, absolute value of X plus 7 equals 9. So X plus 7 equals 9 or X plus 7 equals negative 9. So we have two values of X. X equals 2 or X equals negative 16. And the proposition R, X squared plus X minus 6 equals 0. That is quadratic equation. So we can get the factors. X plus 3, X minus 2 equals 0. Okay? So get the zeros. X plus 3 equals 0 or X minus 2 equals 0. Therefore, the X equals negative 3 or X equals 2. Okay, so the positive values of X, as I've said, no? The positive values of X that makes its mathematical sentence true are 1, 2, and 3 for proposition P. Okay, and then 2 for Q. Okay, and for R is also 2. So therefore, the greatest positive value of X that makes P conjuncts quantity Q conjuncts R is true. Rather, 2. Sorry, that is 2. That is the greatest possible positive value. Okay? Okay, let's proceed to the third one. We have disjunction. So that is the third logical operator. No? Disjunction allows us to express alternatives. So there are two types of disjunction. The inclusive OR, that's the small wedge, and the exclusive or that is XOR. Okay, when we say inclusive disjunction, it is a logic operation denoted by this symbol, usually read as OR, whose meaning is one or the other or both. For an inclusive disjunction to be true, either one or both of the propositions should be true. Otherwise, it is false. Look at this example. 4 is an even number or 8 is an odd number. The inclusive disjunctions 4 is an even number or 8 is an odd number is true, since one of the propositions 4 is an even number is true. Okay? However, in our next example, 1 is a prime number or 6 is an odd number. The inclusive disjunction 1 is a prime number or 6 is an odd number is false. Why? Since both propositions are false. Okay. How about the exclusive disjunction? It is a logic operation denoted by XOR, usually also read as OR, whose meaning is one or the other, same with inclusive, but this one is but not both. Okay? For an exclusive disjunction to be true, exactly one, okay, exactly one of the propositions should be true. Otherwise, it is false. Okay, look at this example. 0 is a natural number or 2 is a prime number. So the inclusive disjunction of 0 is a natural number or 2 is a prime number is true, since one of the proposition 2 is a prime number is true. However, in this exclusive disjunction, it is false. Why? Because both propositions are true. 6 is an even number or 5 is an odd number. They are both true. They are both false, rather. That's why both propositions or the exclusive disjunction is true. Okay? So exercise. So by the way, this is the truth table or truth values for the disjunctions. But this is note that or has several meanings. Okay, or has several meanings in ordinary language. Now, in this case, we use what mathematicians call the inclusive or. That is P disjuncts Q means that P is true or Q is true or both are true. But this one, this is disjunction or the exclusive disjunction, which is if both propositions are the propositions are both true and the propositions are both false, therefore it is false. Okay, look at this. Let P be all mammals have mammary glands, and Q be all reptiles are covered with scales. Form the inclusive disjunctions of P and Q, then determine the truth value of P disjuncts negation Q. What do you think the answer? Is it true or false? Determine the truth value of P disjuncts negation Q. What do you think the answer? Form the inclusive disjunctions of P and Q. All mammals have mammary glands or all reptiles are covered with scales. So determine the truth values of P and Q and negate Q. So what do you think the answer? So both P and Q are true, right? Both P and Q are true. So the negation of Q is false, right? Thus, P is true while the negation of Q is false. Since one of the proposition is true, therefore, the inclusive disjunction is what? That's correct. That is true. Okay, very good. How about this example number 2? Construct the truth table of negation P, okay, exclusive disjuncts negation Q. Okay. First, again, write all the possible combinations of truth values of P and Q. Then, gate the negation of P and Q. Now, determine the truth value of negation P exclusive disjunct negation Q. So this is the truth values. Sorry. Okay. So next in line. So let's try this. Given the propositions below, form the exclusive disjunction and determine the truth value of negation P, exclusive disjunct Q. First proposition, some rectangles have 3 sides. Second proposition, all intersecting lines are perpendicular. So again, some rectangles have 3 sides or all intersecting lines are perpendicular. So determine the truth values of P and Q and negate P. So both P and Q, as we know that both P and Q are false. Therefore, the negation of P is true. Right? Thus, the negation of P is true while Q is false since exactly one of the proposition is true. So therefore, the exclusive disjunction is true. Okay? Last one. Form all possible true inclusive disjunctions of any two of the following propositions. First proposition, 0 is a whole number. The second proposition, the sum of two even numbers is also an even number. And proposition R, any number divisible by 3 is also divisible by 9. So P or Q, okay, the proposition of P is true, right? The proposition of Q is also true. Therefore, P disjuncts Q is true, right? And then the second one, the sum of two even numbers is also an even number. So that is also true, right? So P disjuncts R, or sorry, the proposition of R, any number divisible by 3 is also divisible by 9. That is also, that is false, no? The proposition of R is false. Okay, let us review. P disjuncts Q, which is true or true, therefore that is true. While P is true and R is false, therefore it is true, right? Because there is only one true. And then Q disjuncts R, your Q is true, your R is false, therefore it is also true because there is also one true. Hence, the true exclusive disjunctions are P disjuncts Q, P disjuncts R, and Q disjuncts R. Okay? So those are the true inclusive disjunction. So again, P is false, P is true, Q is true, while R is false. Okay? Okay, next one, for to the last, we have conditional. Conditional propositions or implications, statements that begin with an if or antecedents and those that end with then or consequence. Example, if you are a good at dancing, then you are bad at singing. If a triangle has three equal sides, then it is an equilateral triangle. Hypotheses are antecedents that the if parts of the implications. Example, if you are good at dancing, then if a triangle has three equal sides, that is hypothesis. We have also conclusion or consequence, that is the then parts of an implication. Example, your statement, then you are bad at singing. Another one, statement, then it is an equilateral triangle. Let's continue. How about necessary condition? The hypothesis or antecedents of an implication will only take place if the conclusion or consequent takes place. Example, if you are a human, then you have a body system. Okay? How about sufficient condition? Having a true hypothesis or antecedents of an implication is enough to make the conclusion or consequent true. Example, if you are a female sibling, then you are a sister. That is sufficient condition. Okay? And then again, this is the truth values for conditional. No? As you can see in our truth tables, there is only one false when if your hypothesis is true and the conclusion is false. Okay? So P implies Q is false. Now, how about the converse? A converse of proposition P implies Q has a converse of Q implies P. Okay, that is the implies. No, P implies Q and I think there's a typo error. Q implies P rather. Sorry for that. Okay, that's a typo error. So let's say proposition, if you are good at dancing, then you are bad at singing. And the converse, if you are bad at singing, then you are good at dancing. Again, please, apology for this. I think the typo error that it should be Q implies P. Although the ray is going to the left. Okay, exercises. We have identify the antecedent and consequent in the following propositions. I will go to the mall if I need to buy something. This proposition can be written as if I need to buy something, then I will go to the mall. Therefore, the antecedent is what? I need to buy something. And what is the consequence? I will go to the mall. Okay? How about this? determine the truth value of the implications if x is greater than 0, then Philippines is found in Asia. So what is the antecedents? So the antecedents here in this implication is x is greater than 0, and the consequent is Philippines is found in Asia. The consequent is still true. Okay? The consequent is still true even if the antecedent becomes false. In conditional or in implication, as long as the consequent is true, then the implication is going to be true. Okay? Last one. If P is true and Q is false, determine the truth value of the propositions. Okay. Quantity negation Q, what's that? Or P implies quantity Q and P. Okay, that's a combination of conjuncts, disjuncts, and conditional. Okay, first substitute the truth value of each proposition. So your Q is false based on the given statement. Your Q is false, your P is true, implies your Q is false and your P is true. Okay? Then the disjunction of both. Okay? The disjunction of both true proposition is true. Right? Again, your false is your Q is false. So the negation of false is true. Right? Okay. So the disjunction of both true proposition is true. Thus, we have T or T implies false because false and T is false. And we have T or T, the result is true, implies F. So an implication is false if the antecedent is true and the consequent is false. Thus, this implication is false, right? Therefore, the truth value of negation Q, disjunct P implies Q, conjunct P is false. Okay, are you still there? Okay. Last, state the converse of the conditional proposition and determine its truth value. If a triangle is an equilateral triangle, then it has three equal sides. What is the conditional? A triangle is an equilateral triangle. Then the conclusion, it has three equal sides. Now, identify the hypothesis and the conclusion. Now, what is your converse? Form the converse of the conditional proposition by interchanging the hypothesis and the conclusion. So therefore, your hypothesis now, a triangle has three equal sides. And the conclusion, the triangle is an equilateral triangle. If a triangle has three equal sides, then it is an equilateral triangle. Okay? So, the condition proposition in this example is true because all equilateral triangles have three equal sides. Its converse is also true since a triangle with three equal sides is called an equilateral triangle. Okay, last we have biconditional. That is line symbol in geometry. So the proposition P, if and only if Q. Okay, example, the angle is a right angle if and only if the angle measures 90 degrees. The conditional, if an angle is a right angle, then it measures 90 degrees. The converse, if an angle measures 90 degrees, then it is a right angle. And this is the truth table for the biconditional. Okay, as you can see, the third column, there are only the biconditional truth value is true if both propositions are if the propositions or the first proposition is true and the second proposition is also true, and if the first proposition is false and the second proposition is also false. So the biconditional truth value is true. Okay? They have the same truth values, both P and Q. Example, given the following statements, first proposition, it is an even number. Second proposition, it is divisible by 2. Okay, determine if the biconditional statement is true. Okay, note, P P if and only if Q is logically equivalent to P implies Q and Q implies P. Note that P if and only if Q is logically equivalent this what do you call this propositions or the connectors. No, since that is a conjunctions, it will only be true if both P implies Q and Q implies P are true. Okay. Now, determine if P implies Q is true. So the implications P implies Q, if it is an even number, then it is divisible by 2. This statement is true since all even numbers are divisible by 2. So therefore, P implies Q is true. Determine if Q implies Q is also true. So the implication, okay, Q implies P means if a number is divisible by 2, then it is an even number. So this statement is true since all numbers that are divisible by 2 are even. Okay? And determine if P, if and only if Q is true. Since both implications or conditions were true, P if and only if Q is also true. In other words, it is true that it is an even number if and only if it is divisible by 2. Okay? Okay, last example, we have given the following statements. Princess is an only child and Princess has no sibling. So determine if the biconditional statement is true. So again, this is logically equivalent. Now determine if P implies Q is true. So the implications P implies Q is means if Princess is an only child, then she has no sibling. This statement is true since an only child has no sibling, right? Determine if Q implies P is true. So the implications Q implies P means if Princess has no sibling, then she is an only child. And this statement is true since having no sibling means she is an only child. Lastly, determine if P if and only if Q is true. So since both implications were true, P if and only if Q is also true. In other words, it is true that Princess is an only child if and only if she has no sibling. Okay, and that's the end of my talk. Thank you for listening and keep safe, everyone.
Wow, sir, wonderful presentation with very clear examples in each subtopics. So our dear audience, please let us thank Sir or Dr. Cesar R. Cairo from the Philippines for his very interactive presentation. Thank you so much, sir, and you can wait for our Q&A portion. Okay, thank you so much, sir. Good luck.
Welcome. Welcome.
Okay, so before we proceed to our next topic, I would like to know, or let us recall, what have you learned from the first topic tonight? Can you write it in our chat box? What have you learned from the first topic? Let us make this webinar more interactive. Okay. What have you learned from the first topic? Since you mentioned that this is very useful. So what have you learned from the first topic? Please write it in our chat box or in the comment box. Okay. Amazing presentation. Nice presentation. Thank you so much. Thank you so much, Dr. Cairo. Okay, please write what have you learned from the first presentation or from the first presenter, Dr. Cairo. Okay, according to Sir Eugene, the different connectives. Yes, you're right, sir. Preposition. Wow. Says Mom May. Okay. And Sir Jerry said, I have learned the symbols of the preposition and their truth values. Okay, thanks. Thank you so much, Sir Jerry. And Ma'am Napoleon, there are many applications of the logics in everyday life. Yes, that's true, Ma'am. And Sir Ever, the different truth tables for prepositions. Wow. Okay. And of course, Ma'am Marisa Gumabong, she said, logic from mind, magic from creation. Mhm. And Ma'am Corazon, different types of preposition. Wow. And Ma'am Manolita, logic is critical to make good decision, but it's not an indicator of intelligence. And Ma'am Janine, I've learned a lot, especially that preposition can be false or true. So thank you so much for your active participation in this webinar. Okay, so let's move on to our next speaker from the Philippines. So the next speaker is a teacher from Donna Teodora Alonso High School, and he is a mathematician and public speaker. So please let us welcome Sir Paul Gary P. Abelio from the Philippines. Sir?
Good day. It's my pleasure to introduce myself. I'm Paul Gary Abelio, raised in Manila, Philippines. I completed my baccalaureate degree, Bachelor of Science in Mathematics, minor in Computer Science at Universidad de Manila, Master in Science of Mathematics at Polytechnic University of the Philippines, Doctor of Philosophy in Mathematics at University of the Philippines. I am currently affiliated in the Senior High School Department of Doña Teodora Alonso High School, where I am given the platform to share my teaching expertise in mathematics and in practical research. I am inviting you all to my lecture part on the magic of logic during the international conference organized by the Institute of Global Professionals on July 26, 2021 from 6 o'clock in the afternoon onwards. Godspeed and mabuhay.
So please, again, let us welcome Sir Paul Gary P. Abelio from the
Yes, ma'am.
Philippines. Sir, good evening. Okay, sir, you can start now.
Yes, ma'am. Okay.
Okay. Good luck, sir.
Good evening, everyone. This is Paul Gary Abelio from Doña Teodora Alonso. Yes, ma'am.
Okay. Your presentation,
Ah,
sir. Okay. Okay, let us welcome Sir Paul Gary P. Abelio.
PowerPoint, ma'am.
Yes, sir.
Hold on. I-share ko na, ma'am.
Yes, sir. You can share it now, sir. Okay.
It's okay?
Wait, coming, sir.
Okay. Start na ba po? Start na.
Yes, sir.
Introducing myself.
If you want, sir, you can
Okay.
introduce.
Good evening, everyone. This is Paul Gary Abelio from Philippines. Donyat from Donyat Teodora Alonso High School under the Department of Senior High. Yes. My part is to discuss construction of truth table, the conditional statement, forms of conditional statements, and equivalence statements.
Loading. Okay, Sir Paul, please private. Please rejoin.
Yes, ma'am.
Yes. Rejoin, sir. I think that's not too strong. Okay. So while waiting for Sir Paul, I am going to continue what what have you learned in our in the first presentation in the first presenters. Okay. So logic is very useful in decision making in our daily lives. Yes, that's true, Mom
All right.
Edna. You're welcome back, sir.
Yeah, ma'am, did you hear me now?
Yes, sir, I can see you. So please try to present again your presentation, your PowerPoint
Okay.
presentation.
I'm going to share my PowerPoint. Okay.
Sure, sir.
And here.
Okay. Okay. According to Ma'am Gary, or Sir Gary, I learned five logical connectives that twisted my mind as it's being explained by Dr. Cesar. Okay. Sir Cesar also clearly discussed different types of prepositions. Okay, sir, can you present now?
It's okay now.
Okay, okay. We can see it
Again,
now,
good
sir.
evening, everyone. This is Paul Gary Abelio.
Okay. Sir, your PowerPoint presentation. click the
This is
PowerPoint.
my presentation now.
Yes, yes, okay.
Yes, I'm going to start.
Okay, sir. Slideshow, click slideshow
Okay,
or F5. Okay, or F5 for short.
here. That's it.
Okay, very good. Okay, sir, very good. Good luck, sir.
Okay. Good evening, everyone. Again, this is Paul Gary Abelio from Doña Teodora Alonso High School, Philippines, under Senior High School Department. And my part is constructing a truth table. By the way, what is truth table? Truth table is a mathematical table used in logic. It's usually often used when it comes to Boolean algebra and on the uh, Venn diagram. Okay, the basis for creating a truth table is very simple. We only have three foundation to be discussed here for us to create a valuable truth table. First is negation. Truth table of logical negation is simply as reverses the truth value of a given statement. Again, this is the reverses the truth value of a given statement. If we have P, then the variable of P includes true and false. The negation of P always false and true. That's it. Second, the conjunction. The symbol for conjunction, or simply as and, is a compound statement formed by joining two statements with the connector and both statements are true. If we have the values of P, then the variables of P are true, false, and false. Then Q have true, and false. Then the product of P and Q, true, false, and false. Q conjunctions, always, this is the technique here. Remember this. The technique is when it comes to conjunction, both if both statements are true, then it always true. If both statements are true, then this is true. That is nothing else. The third one is the disjunction, or simply as or. Disjunction is a kind of compound statement that composed of two simple statements formed by joining the statement with or. P, the truth table of P, true, false, and false. Q, true, and false. Then P or Q, true, and true. Let's go back in the conjunction. Conjunction, the magic here is if both statements are true, then the product is true. If both statements are true, then the product is true. When it comes to disjunction, the magic here is at least one statement is true, then it's said to be true. At least one statement is true, then it's said to be true. At least one statement is true, then it's said to be true. That's it. Okay? Example number one. Negation of P, negation of P or Q, what would be the negation of P and Q here? Remember also that the first column of P and the second column of P, they are constants. All right, they are constant. The negation of P, the reverse of P are false. When P is true, the negation of P is false. When P is false, the negation of P is true. When P is false, then the negation of P is true. That is a negation or the reverse. So the product would be The negation of P or Q states the negation of P false and Q true, then it's said to be true. The negation of false and Q is false, then it's said to be false. The negation of true and Q is true, then it's said to be true. The negation of P true and Q is false, then it's said to be true. This is now that hint here, technique. When true and true is the negation, we're talking about here the or. When true and true, it's said to be true. When true and true, it's said to be true. What is the magic when it comes to or? Anyone? What it is the magic when it comes to or? Anyone? What is the magic when it comes to or? Let's go back here. At least one statement is true. At least one statement is true. At least one statement is true. Example number 2 here. The negation of Q. The negation of Q or the negation of Q and P or Q. Then here's the table. Again, P and Q, these are the constants values. Negation of P said to be false. P, when P is true, then negation of P is false. When P is false, then negation of P is true. When P is false, the negation of P is true. Negate P. I'm sorry, negate Q. The negation of T is false. The negation of false is T. The negation of T is false. Then the negation of false is T. Now, on the next column, negate P and Q. Negate P and Q. False, false is false. False, true is true. True and false is true. True and true is true. Therefore, P or Q, we are now here, P or Q, P, true and true is true. True and false is true. False is true. False and true is true. False and false, then this is false. So the product of negation of P or Q and P or Q is true, 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 and true. Again, what is the magic when it comes to true? At least one statement is true. True, true, and true. Okay? One statement is true. Next. Now here, let's discuss the logical equivalence. The logical equivalence, two statements form are called logical equivalent if and only if they have identical truth values for each possible substitutions for their statement variables. This is the symbol for logical values. Here, it's here. Negation of P or Q. Equivalence, negation of P and negation of Q. Thus, the negation of P or Q is equivalent to the negation of P and Q. What would be the answer? First column, state the values of P when there is true, true, false, false. Second, these are Q, true, false, true, and false. Next. Third column is what is P or Q. This is for P or Q. P or Q are true. P or Q, these are true, 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 and false, P or Q. Next column, negate P or Q. The negation of P or Q are the following. If your answer is false, 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 true, then you are correct. Next column, negate P. First, negation or negate P is simply as the reverse. Negate P, these are false, false, true, and true. The reverse of true, the reverse of true, the reverse of false, the reverse of false. Okay? Next column, negation of Q. Still, the reverse of Q. The reverse of Q are false, true, false, and true. Then, the last column states the negation of P and Q. The negation of P and Q are false, 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 and true. Did you get the correct answer? All right. Now, look on the value, look on the column number 4 and column number 7. Column number 1, 2, 3, 4, 5, 6, 7. Column number 4 and column number 7. This is the negation of P or Q. False, 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 and true. And the last column is false, 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 and true. Then this time they are equivalent. All right. Next, let's try more. Number 5. So number 5, these are P and Q if they are equivalent to negation of P and Q. Again, P and Q, these are the constant value. Third column, the product of P and Q. When true and true, these are true. When true and false, these are false. When false and true, these are false. When false and false, these are false. Again, what is the magic here? When both statements are true, then it's said to be true. Next column is negate P. Negate P, negation of P is simply as false, false, true, and true. So therefore, the negation of P and Q are false, 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 false. All right, it's time. Let's try to compare now. What is the product of P and Q? The product of P and Q are true, false, false, and false. Here, P and Q. And what is the product of negation of P and Q? False, 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 and false. This time, they are not equivalent. Okay? Next. Conditional statements. Conditional statement is logically equivalent to its contrapositive. Converse. Suppose a conditional statement of the form if P then Q is given. The converse is if Q then P symbolically. The converse of P and Q is Q and P. The conditional statement is not logically equivalent to its converse. Example, if today is Monday, then yesterday is Sunday. That is the conditional of P. P implies Q. Let's try here. Example number 1. P implies Q. If Paul is in grade 9, then he is a junior high school student. It states its converse. contrapositive, and inverse. Determine whether each statement is also true. Converse. If Paul is in junior high school student, then he is in grade 9. By the way, the word if states its hypothesis and the word then states its conclusion. Okay? Again, converse. If Paul is in junior high school student, then he is in grade 9. Contrapositive, if Paul is not in junior high school student, then he is not a grade 9. Remember here, contrapositive, this is a negation of P implies a negation of P. They both have the word not. Inverse, it should be Q implies P or negation of P implies Q. It's the same for inverse. If Paul is not in grade 9, then he is a junior high school student. Among these three, right? Among these three statements, which is logically true? Anyone? Correct. Among these three statements, the logically true here is contrapositive. If Paul is not in junior high school student, then he is not in grade 9. Look at the first statement. If Paul is in junior high school student, then he is in grade 9. Remember, when we are in junior high school, grade 9 is not only, okay? Grade 9, it's not only the grade level of junior high school. If Paul is not in grade 9, then he is junior high school student. It's very complicated here. Number 2, if a polygon has exactly 4 sides, then it is a quadrilateral. It states its converse, contrapositive, and inverse. Determine whether each statement is also true. Converse. Converse is, if a polygon has exactly 4 sides, then it is a quadrilateral. Contrapositive. What could be the contrapositive here? Contrapositive is, if a polygon don't have exactly 4 sides, then it is not a quadrilateral. Again, if a polygon don't have exactly 4 sides, then it is not a quadrilateral. Inverse. If it is not a quadrilateral, then it is not a polygon. Then a polygon exactly 4 sides. Did you get it? Last example. Ah, if this time will be the end of my session, then I will say thank you. It states its converse, contrapositive, and inverse. Determine whether each statement is true. Converse. If this time, I mean, converse, if this time will be the end of my session, then I will say thank you. Contrapositive. If this time will not be the end of my session, then I will not say thank you. Inverse. If I will not say thank you, then this time will not be the end of my session. And that's it for tonight. Thank you.
Wow, sir, I like your topic, but I think I have to learn more about this lesson, the connection of converse, contrapositive, and inverse. But your example is very clear, sir. Okay, so what a wonderful presentation, sir. I really like your topic. And I think also the audience, they really like the presentation. I think I have to study more the connection, especially the logical, what is that, sir? Logical
Equivalence.
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 Oh, logical
The magic
equivalence. So,
on actually, ma'am, the magic there is very, as I said, that is basic. The foundation.
really, basis, sir?
That's only
I don't.
the magic there. That's really the magic there. If you have the foundation, you are logically speaking.
Yes. Yeah, that's the reason, sir.
Yes.
Well, I'm listening,
Remember,
and then I said maybe I have to learn more about this topic. But I
yes.
really like it, sir. I really like it. Mm-mm. Very interactive, sir. So, dear participants, please let us thank Sir Paul for his wonderful presentation. I really like it, sir. I enjoy it actually. Okay, so sir, thank you so much. And
Thank you.
after our quiz competition, we will proceed to the Q&A portion. Okay,
Okay.
so let's now it's time for quiz competition. Be ready. Okay, time for quiz competition. And the code for tonight. Okay, our code is IGPQUIZO3. Link in comment box. Okay, so wow, we already have 27 participants. Okay, please browse www.slido.com and the code is IGPQUIZO3 or 03. Time for quiz competition. And please use your complete name. Okay. Okay, so we have now 64 participants or players and counting. Okay, use the code IGPQUIZ03. Foundation is the logic. I like what you've said. If you know the foundation, you will know its logic. Yes, that's true, Mom Ida. Okay, right now we have 93 players or participants for quiz competition. Okay, and please write your complete name for your certificate if you win tonight. Okay, very good. More than 100 participants. Yes, Ma'am Manel, we need to study more about the topic. nice presentation. Okay, please use the code IGPQUIZ03 for quiz competition tonight. www.slido.com, and the code is IGPQUIZ03, or yes, 03. Mhm. And right now we have 127 participants and still counting. Okay, let's start. Question number one. Preposition is declarative, while not a preposition is to, interrogative, imperative, or exclamatory. Is it true or false? That is question number one. Okay, 90% answer true, while 10% of the participants answer false. So the correct answer for question number one is true. And 90% of the participants got the correct answer. Ma'am Janice is the number one. Okay. In the statement of P of the, and Q, when P is false and Q is false, then Q is true. True or false? I don't know how to read it. Mm. And the answer for question number two is false. And only 46 of the participants got the correct answer. Question number three. In disjunction of P or Q, when P is false and Q is true, then the disjunction of P or Q is true, true or false. Okay, so the correct answer for question number three is true. Okay, and 84 of the players or participants got the correct answer. Question number four. Compound prepositions use the symbol, as you can see, this symbol, the word, and to denote conjunctions. True or false? Okay, so the correct answer is true, and very good. 86 of the participants got the correct answer, and still the top one is Ma'am Janice. Question number five. If you have 5 apples and 3 orange in one hand and 10 apples and 9 orange in the other hand, what do you have? I have a big hand. Is it true or false? And the correct answer for question number five is false. And 56 of the participants got the correct answer. Wow, Mom Jenny is still the number one. Okay, question number six. Number six. Logic refers to the science that studies the principles of correct reasoning. Is it true or false? Okay, so the correct answer is true, and almost all of the participants got the correct answer. Wow, Ma'am Janice. Okay, question number seven. All dogs have a great sense of smell. Donnie is a dog, therefore logic tells you that Donnie have a great sense of smell. Is it true or false? Wow, difficult question. Okay, So the correct answer is true, and 88% of the participants got the correct answer. And still, the number one is Mom Janice. Okay, question number 8. All squares are rectangles. All rectangles have four sides. Logic, therefore, tells you that all squares have four sides. Is it true or false? Okay, the correct answer for question number 8 is true. Wow, and 90% of the participants got the correct answer. We still have the top one, Ma'am Janice. Question number 9. In negation P, true becomes false. Is it true or false? Okay, so the correct answer for question number 9 is false, and only 15 of the participants got the correct answer. And then now the top one is Mama Rebel. Okay, last question. In conjunction of P and Q, when P is true and Q is true, the conjunction of P and Q is true. Is it true or false? So tonight's the choices is true and false. Okay, the correct answer for question number 10 is true. And 93% of the participants got the correct answer. So now our top one is Mama Rebel, top two Mom Leonora, top three Ma JB A Garapan, and top four Janice E Kachin. I think Mom Janice has two wrong answer. Yeah. Oh, you almost perfect, Mama Rebel and Mom Leonora. Congratulations to the top 10 winners for tonight's competition. I hope you enjoy our quiz tonight. Congratulations to the top 10 and be ready for our Q&A portion. And please, our participants, okay, be ready for quiz competition or the Q&A portion. Okay, congratulations again to our top 10 winners for tonight's quiz competition. Good job. Okay. Okay. Hello, Sir Sess and Sir Paul. We are now
Hello.
on Q&A portion. Are you ready? Okay, our participants, please make sure you address the name of the speaker when you want to ask a question. So make sure you
Who's Sir
write it
Paul?
on your speaker. Where is Sir Paul?
Wait for Sir Paul.
Sir Paul, come back.
Ayan na.
Okay. If you have any questions, please write it in our chat box, and make sure you also address the name of the speaker. Oh, Sir Paul. Hi, sir. Okay, so now we are in a quiz, in a Q&A portion. Okay, are you ready?
Ready?
Ready? Yes, of course,
Yes.
ready. Okay, our audience, please write your question in our comment box, and make sure you address the name of the speaker. Okay, wow, Sir Eugene. We have first question from Sir Eugene. Any of the two speakers, okay, may answer. How is math logic applied in real life? Good question, Sir Eugene. Nice one.
Um,
Okay.
okay, okay, let me first. I try to answer this. Okay, your question, Sir Eugene Gabriel, any of the two speakers may answer. How is math logic applied in real life? Of course, mathematics is not real life, and logical arguments don't always work. This is due to the fact that actual life is considerably more complex and unpredictable than mathematics. The mathematical system is designed to eliminate such uncertainty, but we can ignore the fact that it exists in real life. Or to put it another way, it's there whether we notice it or not. As a result, real life arguments are not as clear as mathematical proofs, which is one apparent source of disagreement. Like in logic arguments, on the other hand, should have a lot in common with proofs, even if they are not as straightforward. And some disagreement in actual discussions is natural, as it arises from actual comprehension about the future. However, some of the conflict may be avoided by employing reasoning. That's where we'll concentrate our efforts. That's it.
Wow, nice answer. Nice one. Okay, thank you so much, Sir Says. And how about this, Sir Paul? What can you say about the
Very
question of
simple
Sir Eugene? Oh, very simple. I like that one.
in
Simple.
real life.
Okay, sir.
Okay, very
Okay,
simple question, a very hard question, but very simple to answer.
answer. Mm-hmm.
If you want to succeed in your life, wake up early in the morning. If you wake up early in the morning, what things you should see first? Clock. Clock is the numbers. Then logically, numbers tells math. Then start doing your house chores. Being a
Wow.
successful man starts on your home. Be responsible.
Mm-hmm.
That's the
Wow.
connection of math in real life.
Wow, very nice answer too. Simple, hard question, but the answer is simple, right? When you want to succeed in life, or when you want to successful in life, you should wake up early, right? And do your task, or do your homework, and or other things you want to finish.
Yes.
Okay, thank you so much, Sir Paul. And now, from Ma'am Manolita Ramos for Dr. Cairo. Okay, from Dr. Cairo, be ready. Recent global COVID-19 pandemic
Thank you.
highlighted the importance on the safety of concern of vaccines were valid. Is the immunization arguments fact or fallacy? Mm.
Uh,
What do you think, sir? We also have here how to love math.
Sir Paul?
Okay. What do you think? The question of Ma'am Manolita. Global
Am
COVID-19 can
I okay?
apply.
May I answer the question?
Sure, sir. Sure.
Yes, may I answer the question, ma'am?
Sure, sure, sir. Go on, please.
Okay. Ma'am, first thing first, I would like to reverse the question to Mama Nolita. Are you vaccinated already? If none, then this is fallacy. If you're vaccinated, that is a fact. Because the Department of Health will not create any communication without antidote.
Yes.
That's it.
Well, clear. Yes, sir. That's a exact answer, right? If you're vaccinated, then that's a fact. If not, that's a policy, right? Very good. Wow, now we have a question from Sir
Yes,
Advocate
correct.
Adam Hikari. Yes, true, sir. To Sir Cesar, why do logic
Ah.
differ from person to person? Differ from person to person. Okay. Why do logic differ from person to person?
Actually, it depends on how to accept the reality or the given arguments. It depends on the people. It depends to the people how to accept or to embrace that arguments for me.
Okay. Yes, how about you, Sir Paul? Do you want to add?
Yes.
Sir
Why
Paul?
do logic differ from person to person? Because, yes, ma'am, yes. Because person's thinking is individual differences. The
Mm,
level of their thinking is different from others. That's the
yes.
Yes.
logic there.
The level of response is also different from person to person. Yes, how the
Thank
way we
you.
respond to a situation is different, right? Some of the people they don't want to
Thank
solve the
you.
problem. Some of the people want to solve the problem. So we have a different opinion
Correct.
or how to respond to a problem. Okay, and so that's why we have a different
Yes.
logic. Okay, so from Ma'am Corazon, how is math logic related to common sense? Nice one, Ma'am Corazon. Okay. Okay. So,
Yes, Sir Paul.
mm,
One
okay,
plus one is
Sir
always
Paul, you
equal
can
to two.
answer first.
I mean, okay, ma'am. One plus one is always equal to two. However, one plus one can be equal to zero because we have integers. One plus
Mm.
negative one is zero. So the relationship of math logic to common sense is very easy. Find ways to know its basic and the foundation of your mathematical thinking.
Wow, very nice answer. Yes, sir, that's
It's your turn,
true.
sir.
Yeah. So, sir, okay, sir says, you want to add more? Please. Mm. Okay, sir.
Yes, sir.
That's
Sir
true.
says,
If you tell to your student that 1 plus 1 equals 3, um, although that statement is false, but for the student that is true. Well, that's the same with the what do you call this the numerical values for me. Well,
okay. So I like both of you. I like your answer. And yes, sir, Paul. That's true. 1 plus 1 or two, but 1 plus 1 is
Ma'am.
also equal to zero, right? It's the integers.
Mm.
Very good. Nice one. So
Yes.
another question, sir, from Sir Neil for Sir Paul. Does mathematician uses logic to prove their theorems? How is that possible?
Because
Sir
of
Paul.
logic, theorems still be theorems. Remember what the theorems. Yes, ma'am. Again, because of logic, theorems is still be theorems. Remember theorems definition? Theorems, these are the law, but uh, theorems, these are the statement to become law, but it is acceptable, but it's the theorems. But because of the thinking of human, or because of man's genuine thinking, then it becomes deeper, deeper, and deeper.
Mm-hmm.
I believe so that mathematicians uses their logic.
Yes, of course. Mm-mm. That's the mathematician should have you they must use logic, right? Yes. Good. I hope, sir,
Mhm.
we answer your question well. So thank you so much, Sir Paul, for that wonderful answer.
Oh.
Okay, another question
Mhm.
from Mom Melanie to both speakers. How can someone improve his her logical thinking? Okay. I think Sir
Ma'am, may
says
I
you
answer again?
sure, sir. Sure. Okay.
Okay. How can someone improve his her logical thinking? Avoid stress. Avoid toxic people. Then sleep tight.
Focus on yourself, right?
Focus.
Avoid
Correct.
stress, avoid toxic people. Hmm. Surround yourself with a good people, right? Okay. Thank you so
Mhm.
much, Sir Paul. How about you, Sir Says? Do you want to add
Okay.
more?
Okay, I think again the logical thinking skills are very important because it can help for to reason through important decisions, right? Like solving problems or generate creative ideas and set goals. I think you have to develop your logical thinking skills by spending time on creative hobbies, so socialize with others, learn a new skills, or try to anticipate the outcome of your decisions, or even the practice questioning.
Yes, yes, yes. That's true, sir. So you also need to be socialized, right? To socialize with other people. Okay. So from Mom Emily, any of the two speakers, what's the logic behind most children of today? If you ask them to do something, they are always complaining before obeying. That is a real life situation. Okay, so who wants to answer first? Sir Says or Sir
Sir
Paul?
Paul.
Sir Paul, this is a real life situation.
Um.
I am one of those students or children before.
Okay.
Okay.
I believe on Sigmund Freud. Sigmund
Mhm.
Freud's statement, tabula rasa. The word of tabula rasa, empty sheet.
Tabula rasa.
According
Empty.
to Sigmund Freud, a baby from 0 to 6 years old, the parents should teach them how to be responsible. So when they reach 7 years old, their thinking is more than enough to think. Okay? Nowadays, children, I'm absolutely saying they are not obeying their parents, because they have their own
Yes.
thinking, they have their own statute. Okay?
Yes.
Because on the process how the parents raise them. Remember, first education should be on their home,
Start at
not in the
home.
school. Yes.
Yes, sir. Yes, sir, Paul.
Mhm. Yes, that's it.
Yes. Education starts at home. Yes, you are correct, sir. So, how about you, sir? Says, do you want to add more about mom question?
Is there a logic?
What is the logic behind those students who are not what is your question? They did not, or they follow, or they complain before following their parents.
I think no. For me, a parent should teach to the child to think critically. No, if the order is logically and in the best interest of student, the child, no, the students may comply if she don't want to do that task or anything apart from their parents. For me,
I
Yes,
agree with sources.
education starts at home, just like what Sir Paul had mentioned. Yes.
yes.
So we should
Mhm.
teach our student or our children to be more responsible, right? Mm. Yes, we have to
Yes.
teach them how to be a responsible children or child. Okay, so thank you so much. We still have many questions, but I think you can answer it, sir, if you want. We have a lot of questions in our chat box, so if you want to answer them, then you can. I love the Q&A conversation. Thank you, Mom Wendy. Yes. We just enjoy it. Okay. Um Start at home. Yes, Mama Marisa, start at home. Amazing answer for both speakers. Okay, thank you, Mama Maricel. Mama Maricel said amazing answer for both speakers. Wow.
Thank you.
Okay. Good answers. Where is that? Good answers from the speakers. Yes, I agree with you, ma'am. Okay. I love the topics and the Q&A. Yes, Ma'am Janet. We love it too. Thank you, sir, dear speakers. I enjoyed your topic. Thought, thought, thought it made my mind really blown. The same with you, Ma'am Ida. Really enjoy this Q&A. My favorite. Yes, I also. I This is one of my favorite section. Portion, the Q&A. Okay. Sir, only one from Sir Rico. How can logic helps us in decision making? Before we proceed to the announcement, I want more logic. Ha ha ha. Okay. Sir, a question from Sir Rico. How can logic helps us in decision making? Last question before we proceed to the announcement. Sir Paul? Sir Paul, can you hear me? How can
From the
logic helps us
basic.
in decision making? According to the question of Sir Rico.
Okay.
Hmm.
Okay.
How can logic helps us in decision making?
All right. Start where the problem started or cause.
Mm-hmm.
Oh,
Yes. In decision making, how does a logic can help in decision making? Okay, sir, thank you so much, Sir Paul. How about you, Sir Says? And then we're going to proceed to the announcement.
I think
The
maybe
question is not
thinking.
understood. Mm.
Sorry. Hello?
conversation, matakot ka sa ganun, no? Nakatayo.
Hello, ma'am?
Yes, sir. Yes, sir, says. Can you hear
Do
me?
you hear me?
Yes, last question, sir, but the question is not posted on the screen. So the question of Sir Rico, how can logic helps us in decision making? Last question.
Mm,
How can logic helps us in decision making?
maybe um, maybe thinking of logic is actually not what should be used in making some decisions. However, the rationality is frequently ignored or drowned out. Let's say about love, like for example in love, drown out in relation by love and even morals. No, personally, I believe that reasoning is not always necessary when making decisions that are truly founded on, let's say, on love and the heart.
Yeah. Yes, that's true. So thank you so much, Sir Paul and Sir Says, for your wonderful answer. We really appreciate it, sir. It's an honor to participate with this
Thank
webinar.
you,
Thank
thank
you,
you.
Ma'am Judy. Thank you, Ma'am Judy. Okay. Most of our mistakes, the big ones at least, are the result of allowing emotion to overrule logic. Yes, we knew the right choice but didn't obey. Yes, so thank you so much, our dear participants, for your active participation in this webinar. Okay, what a wonderful and interactive webinar tonight. Okay, so let us proceed on the announcement. Okay, certificate code must from July 12, 2021, which available on videos session certification part. Okay, certification process. Okay. Without certificate code, no one is eligible for certificates. Remember that. And video will be available always on our Facebook page, website, YouTube channel. Who wants to learn? Anyone can join us on live sessions or later recorded sessions. We don't have any restrictions for learning. Our only focus learn anything you want, but learning is a must. Yes. The beautiful thing about learning is nobody can take it away from you, according to BB King. Yes, that's true. The beautiful thing, okay. For the first time, IGP will launch a virtual award ceremony program as we are different from any other organizations. So in this case, also the same. Okay? Yes, mabuhay. Thank you. Okay, again, for the first time, IGP will launch a virtual award ceremony program as we are different from any other organizations. So in this case, also the same. Okay. Certification process, step by step. And now we have an announcement from our IGP chairman, sir.
Hello, I hope I'm audible. Am
Okay,
I
please
audible?
listen, our lovely audience. We have a very important announcement from from the chairman of IGP, sir.
I'm not chairman, I'm the director.
A
Okay,
director, director. Okay,
I hope I'm audible, right?
yes, sir.
Okay, dear participants, before move to certification process, I want to say something. That is, today, I think you don't claim your certificate for tonight. Cause of restriction from inter-server and the same from Namecheap. Because we said that lots of the issue in the most of the case we are dependent for others. That is, in this case, our website is in under maintenance by inter-server, which from our end everything is okay. From our website is completely okay, and this issue is from inter-server. I think maximum of you know the name of inter-server uh, for actually cloud hosting server. So they're doing their maintenance, and they started it before 6 hours, and they say it will take 6 to 8 hours. That means it can open or it can run anytime. So just for today, only for today, just confirm or just collect the certification link and code. Just note it, link and code. You can try anytime with the link and code. So you don't think so that if you miss this certificate, on behalf of IGP, I promised I will assure more than 50 certificates for you from IGP if anyone missed today's certificate. So no problem from IGP, because actually everything is okay from IGP. But our hosting partner, our website hosting partner, that is Inter server, they are actually doing maintenance for today. Actually, they started 6 hours before, and I hope lots of participants who tried from 6 hours to before 6 hours, so they all are not able to join, not able to uh, sign in our website for the last 6 hours. So no problem. From our end, everything is okay. Everything is okay, and it is only for inter server. They're just doing their maintenance. So that's the case. I hope you will get your certificate by any time. Just collect the certification link and also the code, which is very important. So this is a cordial request for today, only for today. Please actually from inter-server team, they apologizes us and they requested to ensure me they will open it, or their maintenance will cover within today. So anytime our website will be open again. So no problem from again, no problem from our side. So you have to collect the certification link for today, only for today. This announcement is only for today. Dear participants, we are extremely sorry for that kinds of inconvenience. Actually, this is not our fault. As we said before, at the most of the case, we are dependent with someone, some others. Like in this case, we are dependent in Namecheap and InterServer. So InterServer is our hosting partner, and Namecheap is our domain partner. So in this case, we're dependent on that, and they are doing their maintenance. So that is the case. We're extremely sorry. So for today, this is my cordial request to you. For today, only for today, please collect the certification link, which now available on every pin comment. On every pin comment, we are right now we have we have around 300 participants right now. So it's a cordial request just for today. Collect the certification link and also certificate code. You can try it anytime. I hope very soon they will complete maintenance and they'll open all the website. This is not only for my website. This is happening all the website from all over the world, because InterServer is the worldwide hosting provider from USA. So not only we are the sufferer, lots of uh, I hope lots of website holder or website owner are facing the same problem. So again, this is for extremely sorry on behalf of IGP. We said lots of announcement we have, like one of them is award ceremony program for the virtual. I want to say just a single line. It's also be, maybe it can be free. It can be also free, and we don't want to say the we don't at the moment we don't want to say clear total procedure, because lots of people, lots of organization follow IGP. If we plan anything, if we share anything, then they steal our plan and they copy it in their organization. So that's why in this program, in this case, in our ceremony, we don't want to explore details before. So when we are launching on that time, you can say that I guaranteed that it also be completely different from any other organization. So thank you so much. Again, sorry, cordially sorry. Uh, we don't actually. This is in not in our hand. And from August first, we will arrange a free webinar daily. And another one is IGP is completely free for you all. Our webinar, our program, everything is free for you, free for participants. But everything is not free for IGP. So we need your support. I hope you will do that. Thank you so much. Move for the next process. Ma'am Rohamina, please carry on.
Okay, thank you so much. Thank you so much, Sir Kaushik Data, Director and Founder of IGP. Thank you so much for the clarification. So because of the maintenance, so our page is not available. Okay, so 26th July, today's program name, Magic of Logic. This is the step one. You will have to find the title of the webinar tonight. So, which is Magic of Logic. Okay, certification link, https eudigp.com courses Magic of Logic, and certification link now available in comment box and pin comment. Certification link will be available always in this program post, Facebook page, Facebook group, and YouTube description. Okay, that is the step two. Okay, certification process. You can claim your certificate in two ways. You can direct link from comment box, pin comment, for post description, or if you are not able to click this link, please directly browse www.eduigp.com for all the information together. Find today's program, then the process are the same. Okay, so remember that we have two ways in in downloading a certificate. Okay, step three, browse www.eduigp.com or given link you will direct in this page of our website, and just click enroll now. Okay, remember our topic for tonight is magic of logic. Okay. Okay. If you are new, create your account, and then if you have an account, then log in directly. After that, find the seminar title and get enrolled. As you can see in the right side, if you are new, please log in, or if you are new, please create a new account. Okay, then log in and get enrolled. Okay, instructions, certificate code required. Today's program name, Magic of Logic. So our lovely participants, the code for tonight's webinar is IGP321. I repeat, code for tonight's webinar, IGP321. And remember, without code, no one is eligible for certificates. Okay, remember our IGP code is IGP321. Okay, I hope You remember our code for tonight is IGP 321. Without code, no one is eligible for certificates. Announcement. Please note, quiz code and certificate code are not the same. Okay, so the code you use in quiz code is different from the code of getting a certificate. Okay, so remember that this not the same. So this is the step 5. With code click get your certificate. So using the code IGP321, then click get your certificate. Okay, very okay. And today is the today's topic, magic of logic. Okay, you have to use this code IGP 321 or 321. Our free international webinar certificate is auto-downloadable in PDF file. So check your device file manager. Sometimes it looks uncompleted, which is for your mobile screen size. In PDF file, everything is okay. Yes. If nothing found
Hello,
in your
hello,
file manager, yes, sir.
hello, ma'am.
Yes, sir.
I saw
Yes.
that in the comment section, still some of participants are asking that link is not working.
Ah,
I say there will before that for today, please collect the certification link and certificate code. After that, you can try it anytime. But you have
yes,
to
yes.
wait some while, right? You have to wait some while because they say
Yes.
they will complete with their maintenance within 6 hours, but it's almost
Yes.
crossed 6 hours. So this is not in
Yes.
our hand. You can try it after 2 hours. Even though you can try it tomorrow. Even though if you want, you can try it after 1 years. We don't change our code for at least 1 years. So don't think about that for certificate. Please at least follow
Yes.
some words which I already said. For today, please collect the certification link and certificate code. So which is the main point? Certificate code and certificate link. So after
Yes.
that, you can try it tomorrow. You can try it after 2 hours. You can try it anytime. No problem.
Mm.
So you
Yes.
don't
Yes.
need to you don't need to mention several times that link is not working. Link is not working. Because actually,
Mm.
I already said everything, and then I
Yes.
applies it that this is not in our fault. This is
Yes.
based on
So
our partner fault.
yes, this is not the problem of IGP. So our
It's
lovely
still the
participants.
it's
Mm.
still now actually right now I said again the same procedure, and in the comment section, someone asks still page not found. So what I said
Okay.
right now,
So
what I said in the
the,
last 5 to 10 minutes. This is
yeah.
the same
Okay.
now.
Yes.
So you
Yes.
have
So
to
our
consider. You
participants.
have to realize at least. You have to realize our problem. I
Yes.
said
Yes.
that this is not our problem for today's certificate. Only for today's certificate, you have to
Because of the
collect the certification
maintenance.
link. You know, this is not in
Yes.
our, this is not our fault.
Yes. Okay,
Just
so our dear participants, you can claim your
Rick,
certificate tomorrow
another
or
one.
maybe after one
O-
hour. After one
Okay,
hour.
okay, ma'am. Another one, Ricky. How po? This is my first time to attend. No, attend
Ah,
now
okay,
again.
okay. So
Okay,
that is his first time. So Sir Ricky, so due to the maintenance in the website, so our page is not available. So just remember the code for
okay, ma'am,
tonight's
ma'am, ma'am, ma'am,
webinar.
ma'am, ma'am, ma'am. Let me.
Yes, sir.
Sir Ricky, you don't have to take any tension or any kinds of. Please don't be panic. Our core team member Janet Escablau and Ma'am Janet Escablau and Sir Calvin Leonardo is always ready in the comment section. You can
Yes.
message them. You can message them personally. No problem. They will guide you how to claim your certificate, how to join our webinar. And
Yes.
another one point I received, that is someone said, please from next, if possible, something like that, if possible, make it easy access like Zoom. Dear sir, uh,
Mm-hmm.
for the last 11 months, we run this IGP, and based on Zoom restriction, our IGP, in the IGP, we received more than 1,000, at least highest 1,000 participants we received in the live session. So we can't
Yes.
do that on Zoom because Zoom has restriction. If you go, if you are in the free version of Zoom, then they can allow only 100 participants. If you are in paid version with $30, they will allow 200 participants. If you are in paid version with $50, they will allow 300 participants. So you should also consider, na?
Yes. Okay. So they said, sir,
Our
you
team
don't need to
member,
say
again,
sorry.
our team member Calvin Lilatok and Ms. Janet Escablo, always in the comment section to help you
Yes.
to find a better solution. So don't get I think please stay with us and consider us. This is not our fault. Again, this is not our fault.
Yes. This is not our page is under maintenance. So you can download your certificate maybe after 1 hour, or you can download it tomorrow. Since
Yes,
we
you can
already
download it
gave
tomorrow.
you
Also, you can
the
download it tomorrow. No
code.
problem. And
Yes,
you
no
can try
problem.
it after, you can try it after 1 hour also. Their
Yes.
work is complete, then they will open every website. This is not only for my website, this is for all the website of our inter-server partner.
Yes,
So
sir.
this is not only for me.
Yes.
I'm the not only the single sufferer.
Yes, sir. So I think everything is clear, sir. Okay, so when everything is okay, please you can download your certificate because our page is under maintenance. Okay, you can join our all live programs from Facebook page, Facebook group, YouTube channel, and website. If anyone missed any program due to some unavoidable issues, still you can attend previous webinar with verified certificate. Okay. Dear participants, if any problem raised to claim your certificate or any other issues, please don't be hesitate to contact us. If now our website isn't working well, don't be panic, okay? Our participants, please don't be panic. It's issue of traffic codes of max user. You can claim your certificates tomorrow also. Our core team members are always ready in comment section to support you to find solutions. Sir Ma'am Janet S. Cablao and Sir Kelvin Linatok. Okay, so you can ask Ma'am Janet and Ma'am Kelvin. Sir Kelvin rather. Okay. And our upcoming webinars, July 26, 28 or rather July 28. The topic is special topics in general mathematics. So I also read in some questions they're looking for the general mathematics. So please don't miss the webinar on July 28th. The topic is special topics in general mathematics with two speakers from the Philippines. Okay. So, July 30, our topic or the topic is global hospitality planning with modern travelers with two speakers from Philippines and also from Bangladesh. Okay. August 1, 2021, the topic is empowerment through education with 3 speakers from Bahrain, Trinidad and Tobago, and also from Nigeria. It is a wonderful webinar, so please don't miss it. Okay, so August 3, 2021, topic setting career goals with 3 speakers from Singapore, South Africa, and Albania. Okay, and August 5, 2021, topic self-determination leads to success with 3 speakers from Morocco, United Kingdom, and United States. Okay. Book your seat. Please check and confirm our program time with your time zone. Evening session. Yes. 6 p.m. Bangladesh time. Okay. So August 7, 2021, the topic is transcending optimism and research-based practices in education with 3 speakers from the Philippines. Okay. And August 8, 2021, the topic Human Resources and Conflict Management with 2 speakers. Again, our speakers are from the Philippines, Dr. Auridia and Dr. Sherhan, ND. I hope I pronounced your name correctly. And August 9, 2021, topic Transforming the Future Through Education with 3 speakers from South Africa, Tunisia, and also from India. And August 10, 2021, the topic Global Communication for Educators with 3 speakers from the Philippines and from United Arab Emirates. So please don't miss this wonderful webinar. Okay, August 11, 2021, the topic Developing Resilience with 3 speakers from United States, Nigeria, and India. Okay, so we have the webinar on August 12, 2021, topic Creativity in Teaching. So I know you know these 2 speakers, Sir Emmanuel F. Del Rosario and Sir Feruz Akbarov from Uzbekistan, and Sir Manuel is from the Philippines. Creativity in Teaching. August 13, 2021, Leading Change Through Uncertainty with 3 speakers from the Philippines, South Africa, and United States. August 14, 2021, the topic Socio-Emotional Learning with 2 speakers from United States. Okay, so please don't miss this wonderful webinar on August 14. And August 15, 2021, topic Transformational Leadership with 3 speakers from the United States, United Kingdom, and South Africa. And upcoming August 17, Leading for Success with 3 speakers from South Africa, United Kingdom, and Ecuador. And August 18, 2021, the topic Facts and Figures of Ancient Mathematical Techniques with 2 speakers from Oman and from India. August 19, topic Community Engagement and Empowerment with three speakers from Vietnam, India, and of course from Nigeria. And August 20, 2021, we have topic Concepts and Components of Quantitative Research with two speakers from the Philippines, Sir Jonathan and Sir Mark Rostom. August 21, 2021, Achieving Success Through Innovation. Wow, with three speakers from United Arab Emirates, South Africa, and Croatia. Upcoming soon, August 23, the topic Leadership in Education with three speakers from South Africa, Switzerland, and again from Croatia. And August 24 or 25 rather, Social Emotional Teaching and Learning Management with three speakers from Greece, India, and Georgia. Okay, so August 27, topic Thriving for Success with four speakers from South Africa, India, Nigeria, and of course from Singapore. And on August 29, 2021, we have the topics on principles of leading change with three speakers from South Africa and United, with four speakers rather, from South Africa and United Kingdom. And please don't miss this wonderful webinar on August 29. Okay, August 31, Young Leaders Changing the World with four speakers from South Africa, United Kingdom, and Vietnam. Okay, September 1, 2021, Redefining Education from India. We have two speakers on September 1, and they are from India. Okay, September 3, Importance of Co-Curricular Activities in Teaching and Learning Process with three speakers from India and Sri Lanka. Okay, so please don't miss this wonderful webinar. And September 5, 2021, the topic Technology of the Future in Education, Advantages and Challenges with three speakers from Croatia and India. Okay, September 7, ICT uses in everywhere. We have we have three speakers from India. Okay, so please don't miss this webinar. And September 9, 2021, 21st Skills in Education and Integration of Technology with three speakers from Albania. Okay, September 11, topic Supporting Learning Through Interactive Learning Tools with three speakers all the way from the Philippines. Okay, September 13, speaker research methodology and literature. So I know you know there's two speakers from the Philippines. So please don't miss this wonderful webinar on research methodology and literature review. Okay, September 19, psychosocial issues of students with three speakers from India and Australia. Day off. September 23, day off. We have a day off on September 23. Okay. Coming soon. September 30. Okay. So this is an example of a certificate of participation. So as you can see on your screen, and this is for lifetime and membership and also the host certificate. Okay, so global volunteer. Okay, participants. If you're interested, we are looking for some dedicated volunteers to do a post video creator and post customer service representative. Okay, global volunteer. You can join. Okay, so thank you so much IGP, and I hope you learn from tonight's webinar. So see you all in our next webinar. Thank you and good night. Huh? Albania? Okay, so upcoming. Okay, so this is our topic for the webinar. Okay, so please don't miss the webinars in IGP. Okay, so remember the code for tonight's webinar is IGP 321 or IGP 321. Okay, without code, no one is eligible for certificate. Okay, so you can try to download your e-certificate tomorrow or after 1 hour because we have a maintenance. So that's why our page is not available. Okay, so thank you so much for tonight's webinar. Good night.